All right, time for another lesson. It says in the mental math here that, so suppose angle ARC is congruent to angle NTY. Okay, so that means that this angle is congruent to this angle. It says RD bisects ARC. That means that these two parts are congruent. I'm going to put curvy dervies in there to show that. It says TH bisects NTY. Well, since the two angles are equal and they're both being bisected, that means all four of those little angles are equal. This angle DRC is 4.5x. I'm going to write that there. Wait, that means all of them are 4.5x. Each one of those little four angles is 4.5x. So find each measure. HTY, that would be 4.5x. NTY, okay, that's this. That would be 4.5x plus 4.5x, that's 9x. And then angle ARC plus NTY, that's this angle and this angle, that's 9x plus another 9x, that would be 18x. All right. Now in the warm-up, it says the segments AB and CD, something, they have the same midpoint as shown here. Okay, so that means this is congruent to this, and this is congruent to this. It says, consider the list of justifications. Okay, so you're matching 1, 2, 3 with ABC. So, okay, the measure, number one, it says the measure of angle AMC plus the measure of angle CMB equals 180. Well, when two angles add up to be 180, they are supplementary. So that would be C. Angles in a linear pair are supplementary. Okay. Number two, it says, you're going to have to excuse my laptop here. Apparently, I have VIP access to RAID. Can you go away, please? Okay. Oh, no, accidentally opened it. I love how that just happens randomly while I'm filming a video. Whatever. Measure of angle AMC equals measure of angle BMD. Oh, okay. AMC is this angle. BMD is this angle. Those are vertical angles. So that would be letter A. Okay, then number three, it says angle AMC is congruent to BMD. Two angles have the same measure, then they're congruent. I guess that would be B. Interesting. Okay. All right, next, it says, write the congruent statement using the vertices, then use CPCF to justify a conclusion. Just one. I can handle that. Okay, let's say A, B, C, D, E, that shape on the left, A, B, C, D, E, is congruent to A corresponds with R, B corresponds with S, C corresponds with T, and so on. So it'd be RSTUV. Whoa. UV. There we go. All right. And we have one more warm-up. Wow, lots of warm-ups today. It says let CDAB be congruent to GHEF. Find x if the measure of angle B equals 3x minus 12 and the measure of angle F equals 2x plus 15. B and F are congruent angles because of CPCF. So that means that 3x minus 12 actually equals 2x plus 15. Now if we solve that out, you're going to get x equals, I'm just going to add 12 while I'm at it. I'm going to skip a couple steps here. 15 plus 12 is 27. X equals 27. There you have it. Okay, lesson 5.3 is called one-step congruence proofs. And the essential question is, how can figures be proven congruent? So notice the rest of this note sheet is nothing but proofs, right? Nothing but proofs. So when you are making a proof, you start by making a T-chart, okay? And on the left side of the T-chart go these things called conclusions. Conclusions are things that you know. When you draw a conclusion, you are stating something that you know to be true, okay? So on this side of the T-chart, on the left side, we're going to write down things that we know are true. On the right side, we're going to have to justify with justifications everything that we conclude. So if you say something is true, you have to tell why it's true or how you know it is true. That's what's going to go on the right side, how we know it's true. We're going to justify every conclusion that we make. So in example 3, they are giving us the information that we have two congruent triangles. And we're supposed to show that those two segments in the end are equal. So you always, not always, but most of the time, you're going to start with the given information when you're making a proof, okay? And I realize this is the first time that I'm talking about actually proving something. So this is totally foreign. So I'm going to take it nice and slow, but you most of the time start with the given. They're telling us, the people who made the problem are telling us that it's true that those triangles are equal. So then let's think to ourselves, how do we know that QR actually does equal TU? Well, look at the conclusion that we just made. We are saying QR and TU, they're the same first two letters. What's that called? That's from another digital lesson I learned, or I taught. When the letters match up, CPCF is the theorem that tells us that those are congruent parts within those shapes, okay? So CPCF allows us to actually conclude that QR is equal to TU, all right? And that's the end of the proof. Notice that this lesson is called one-step congruence proofs, meaning there's only one step after the given. You don't really count the given as a step because it's just given information. But you can still write it down as a conclusion because you have a reason to conclude it. It was given to you. Let's just try another example. Okay, example 4. It says M is the midpoint of AB. I'm going to draw a picture of this. I just think it will help. So M is the midpoint of AB. And it wants us to prove that AM is equal to MB. So again, you start by making a T-chart, you put conclusions on the left, justifications on the right, and normally you start with the given. So M is the midpoint of AB, segment AB. So the question is, how do we know that AM equals MB? I think it's because of this word right here, midpoint. Midpoint means that it's right in the middle of the segment, okay? So it's because of that word that we know AM equals MB. So whenever it's because of a specific word that you know something, it's because of the definition of that word. It's the definition of the midpoint that tells us that, okay? It's the definition of the midpoint. Now we're on example 5. It says, given P is parallel to Q, okay, so these are parallel. I'm going to put arrows on there to indicate that they are parallel. That's what the arrows mean. It says, justify the conclusion that angle 4 is congruent to angle 6. All right, so we know that P is parallel to Q because it's given. Why would angle 4 be congruent to angle 6? Well, those are corresponding angles. And we learned, well, I'm going to teach you in person. Actually, I think the next time we meet that corresponding angles are equal when the lines are parallel. So that's called the corresponding angles postulate. I'm just going to write corresponding angles. So that's how we know that angle 4 is congruent to angle 6. All right, now we're on the last, well, we're not on the last one, but we're getting there. It says given P is parallel to Q again. All right, so I'm going to put the arrows on here to show that they're parallel. It says prove angle 1 is congruent to angle 5. Oh, this is going to actually be more than one step. Hope you don't mind. So we've got conclusions and justifications. So, okay, it's given that P is parallel to Q. Now, because of corresponding angles, we know that we're trying to connect 1 and 5. We can connect angle 1 to which other angle? Angle 3, because they're corresponding. Now, angle 3 is vertical to angle 5. Angle 3 is therefore congruent to angle 5 because of vertical angles. Now look what I have here. I have 1 is congruent to 3 and 3 is congruent to 5. So that means that we can now connect angle 1 to angle 5 because of the transitive property. Okay? The transitive property allows me to connect these two things that are connected by angle 3. All right, so I'm just going to write transitive there. Because both angles are congruent to angle 3, that means they must be congruent to each other. Okay, now last but not least, we have one more here. It says given that the measure of angle 2 is equal to the measure of angle 4, that's given. It wants us to justify the conclusion that x is parallel to y. Well, 2 and 4 are corresponding angles. You can see that. They're corresponding angles. So that's why x is parallel to y. That's only a one-step proof right there. This doesn't have the same impact as if we were meeting in person, but at least it's something. Have a great day. Goodbye.